proceed. And so we're going to say, I don't know, void get cstring, actually not a void, but char, a pointer to character. That's what the cstring is, pointer to character. And I will simply return the address of my array of characters, right? So address of my array of characters is a perfectly organized C-string because it will contain perhaps some characters, and then also it will, you know, basically provide user with access to this array of characters through the character pointer. So as you know, array names contains the address of the first character. Therefore, address of the first character is a perfect object to initialize pointer to character. And then, of course, I should be able to just send that to my cout and be able to print it. Also, I am noticing that when I construct my string, it should be, for the sake of safety, I should probably also initialize this first element of my array to 0, so that it's the end of string is right where we stand. So when before I append, I should be able to print empty string, and that should not be a problem because it's just an empty string. The whole array just contains some garbage, you know, in memory, but I'm making sure that the first character is 0. Therefore, when I call cout and say, hey, display this for me, which returns a character pointer, it will try to process all characters, but it will immediately find the first 0, null terminating the null character terminating the string, and will be ignored. Then I append, and this should be all visible. So let's compile and run this. If I didn't make too many mistakes, then we should be able to compile and run it. So build, right, and run. So this time an empty string is printed, and then AB is printed, which is expected. Now, the user start liking my class a lot, because they say, oh, this is really kind of cool string to use, and would like to use it. But this they tell me, this is how we would like to be able to use it. Instead of saying string append, and so forth, could you give us this? So we'd like to be able to say, we have an object, call member function, say that we want to append, and could this entire function return back a reference to this very object? And then therefore, immediately we can call another append on it. We call this chained member function calls. Well, this is easy to allow, because all I have to do is to modify the version of my append to return a reference to string, right? Instead of returning void, this time return a reference to string, and then simply return dereferenced this pointer. Perfect. So now what happens is that the append will be called the first time. Let me make sure that we can actually see everything on one screen, right? So we have this append member function, and what happens here is that we create an object. We know that the constructor does some nice job making it look like an empty string. So the constructor is invoked right here. It gets, you know, it does its thing. Then we basically say get cstring, and we make a call, and we print it. We print empty. But then we say append. So append gets called as a normal member function right here. The append gets called. And it does its thing. It appends the character, increments the length of the string and all that. But eventually it says, well, I will return string back, string reference back. And so you can then use this entire expression as if this was S1, right? Because calling append returns back reference to S1, because it's the only object that we have so far. And so then, because I have gotten the reference to string, I can call another append immediately, and that's a chained function call situation. This doesn't prevent me from calling S1 append and entirely ignore what append returns. I really don't care. Maybe I just want to append a single character, and that's fine, it'll work. But if I wanted to chain these calls, it'll work too. So to allow the syntax, we have the slide that demonstrates that sometimes you want to have a function which returns a reference to an object and use the this pointer, which basically says return myself. We will see more and more of examples of functions like this, which return a reference to instance of our class. Please let me know if you have any questions. If not, I will move on. So we can actually save this. Well, let's make sure that this builds fine. Right, and so there you go, A, B, C, and so forth. So let's. I can post this as an example on our website. Let me just save this as name this demo 01 or something like that, and so I can post this demo. All right. Interesting topic here is that references as members. Perhaps we can modify what we have so far. If instead of using character array in the second version of my string class, I simply create an adapter of an existing string. Say string, okay, string mstr, something like that. I no longer need length because the string will provide the length. So I will just proceed to modify my code. I really don't. I no longer need the default constructor because the string will be using its own default constructor, and it does everything perfectly well. And hopefully, if I want to say append, all I need to do this time is simply say mstr, basically append, and append character ch, right? So it already knows how to do the append operation. So is there something that I did wrong? I don't know what this is unhappy about. Let me try to compile this. Get C string. So this time, what I will do, I will return mstr, and there is a function just like that inside the string. What I will do here is to make sure that I return a const pointer to satisfy everything and declare this function const. We will talk about this a little bit more. So let me try to compile this code to make sure that it compiles and I don't have anything strange happening here. So it's unhappy about something, and that something is error, a basic string append cannot convert parameter 1 from char to const basic string reference. So it's unhappy with the character here? Okay. Um, okay, I'll do something really stupid here just to make sure that it compiles. String. Apparently something like that will work. Let's find out. Yeah, no. Get some garbage here. So it's in reverse. Like construct a string from one character, and then append this string to the embedded string that I keep internally in my string class. Notice that my string class uses uppercase name of the class. So okay, so it works as expected. That's fine. Now, the point of this demo was to make this modification. What if my string doesn't want to create its own string? Basic string, the standard library string. What if I need a constructor which takes a reference to a string, standard library string, and then I can use my constructor, and these are actually not constructors but operations right here. So this particular constructor, now I require that that first of all I will store a reference to string inside my class, not a copy of the string. I will say, you give me the string, I will act as a wrapper around that string, and I will store a reference to the string. So, which means that I can no longer construct a string with the default constructor. Instead, string original, right? That's the original. Then construct string by using the original. The original string will be used to give it to the string constructor. This constructor will take a reference to this to the string in my main function, right? So original will be passed by reference to this constructor. And then what I need to accomplish is this: store reference in my string, right? So I have a reference in my class. Somehow I get this reference from the user, and I want to remember it. This is not going to work, basically, because this is too late. It looks like assigning this string to this string. This is too late for constructor. And the workaround is that C++ allows member initializer lists. There, it's not a construction, it's not an assignment of any sort. Basically, I will take this out of here and get rid of it. Instead, what I will do, I will say, construct my reference from this reference, and like using constructor syntax. And this is called initializer list, because it can be a list. I can do more things on this list. But for now, I just have one member that I want to initialize. So what changed in this situation is that instead of having my class create brand new string, now I say, hey, the user has to provide the string. I will capture it. I will remember it by reference without making a copy of it. And then from that point on, everything else should work, because, you know, once initialized, reference behaves exactly like the original object. Bless you.
Thank you.
Right. So let's run this code and see what happens. So I never compiled it, so let's build this. There you go. It behaves exactly the same. So this is interesting, right? This is interesting behavior and interesting things that are that we discover. And again, you cannot initialize a reference inside the body of your constructor. You must use the initializer list. This is the only way for us to be able to uh, initialize a reference to another object inside our uh, our class. Before we take a break, just another little demo that I'd like to show you is that uh, if if we had by the way, any questions about this so far? So again, now we require somebody who is using our class to provide some string, the standard library string. We're going to wrap around it, remember reference to this string, and then we'll do our work with it. But then the remaining part is unchanged because from that point on, the interface of our class never changed, so everything works as was, as before. Same append, same get cstring, everything works. So here's another constructor, just another thing before we take a break. Another constructor, which instead takes a pointer to the string. Well, I guess, you know what? Let me kind of undo what I did so far. And let's say that if I wanted to remember a pointer to my string, okay? So first of all, I can no longer call append because this is a pointer. So I have to use pointer dereference to member operator to access append, and also need pointer dereference operator to access another member function which I need to access here, right? So this gives me access to cstring. Standard string provides that through a member function named cstring. What it does, it returns a pointer to a sequence of characters which represent the string. So this all works, but this time, if the constructor requires a pointer, of course I need to change this to say take address of original, and then the address is a perfect object to initialize a pointer to string and then store pointer. Because pointers are mutable, they can be changed, that's not a restriction, then in case of a pointer, I could easily do this. That's not a problem, right? I'm dealing with two pointers, and so this, instead of initializer list, I could just use this. So let's make sure that it all runs the same way. So yes, sure, build it and run it. Right? So it all works the same way, but it's just another demonstration, this time using pointer, right? So I could probably name this Peaster and so forth, and this should probably be like Peaster or something. I kind of like to name pointers slightly with a hint that it's a pointer, right? So like pointer to string, pointer to string, and the pointer to string here. Hopefully that's all changes that I need to make. However, I would still completely prefer an initializer list to the possibility of doing this. Essentially, when you deal with members, with the data members of your class, the initializer list is the way to go in C++. This is the way to initialize your data members. Later on, I could do something like this. System-wide configuration. Do something like that. I don't know what the system-wide configuration is, but if sometimes this portion of the constructor could do something else, right? So it's possible. So this is a semicolon, right? So, but simple, straightforward members of our classes should be initialized like this. For example, I could say integer m counter of some sort, right? I don't know, counter of whatever I want to count. In that case, I would expand my initializer list to say, okay, counter, and perhaps initialize my counter to 0. Okay, so this is a version of the initializer list with now 2 data members, right? So very practical. It's just a little additional syntax, and this guarantees that there's no time wasted in any shape or form, because sometimes this is too late. So initializer lists have very heavy use in C++, and pretty much all constructors typically use this syntax as opposed to member assignment syntax to provide values. In Java, this is the only thing you get. In C++, you have initializer lists that are available to the syntax of your constructors. All right, so let's save this fragment, and perhaps I don't know